Okay, this is Mr. Gillum, and today we're on Lesson 8, Day 3 notes in your instruction book on page 74. And we're going to be dividing with 5-digit dividends. So the numbers are going to get larger today. The first example says that Sam's father bought a new car for $26,304. He expects to pay for it in 24 equal monthly payments. How much will Sam's father have to pay each month? So this is actually a real life example because I have purchased many big purchases in my life, and they tell you if you don't have to, or if you pay off this in a certain amount of time, you will not have to pay interest. It's called 0% financing, and so it's important that you do pay it off in time, and you do know how much you have to pay, or you get you have to pay the interest on it, which is usually several $100s. So anyway, in this specific example, he bought a new car. He has 24 months to pay it off. He wants to pay off the same amount each month. So one thing we could do to just consider this problem about like what a reasonable answer would be just to estimate. And so I see that he in the book they rounded 26,000 down to 24,000, and they kept 24 the same. And the reason they did that is because they know that 24,000 divided by 24 is a quick calculation, a mental math calculation of $1,000. So now, because this is an estimation, it's not exact. I know that really he has to pay more than $24,000, so I know that my answer should be a little greater than $1,000 per month. So my estimate's a little low, but it's going to be a little more than $1,000 per month. So what we could do is we could use a division algorithm to solve the problem, and I'm going to show you that, and I'm also going to show you, this is the division algorithm, and this is the partial quotient method, because I think that I may have confused some of you on that, so we're going to look at it again. So the division algorithm, I have 26,304 divided by 24. And so I approach this the same way that I have all my long division. I look at the 2, I see that 24 does not go into 2, so I look at the 26. 24 does go into 26 one time. Take away 24, and I bring down the next number. Now I see that 24 does not go into 23, so since I'm looking at the third, so let me make sure I'm clear about this. When I was looking at 26, and I knew that 24 goes into 26 once, I put the 1 above the 6. That's the last part of the number that I was looking at. It's important that you align the 1 in the correct spot so that you know where the decimal goes and all those other factors as well. 24 goes into 23 0 times, so I take away 0. 23, I bring down the next number, which is 0. Now, I know 24 times 10 is 240, so I'm going to say that 24 times 9 is going to be just under 230. And so when I do that calculation, looks like I get 216. When I subtract, I better do the borrowing just in case someone's still not clear about that. 14, and I bring down the next 4. Now I need to estimate again. I need to figure out what times 24 is going to be close to 144. Well, I know 24 times 10 is 240. Half of that would be 120. That would be 24 times 5 would be 120. So another 24 would be 144. I know that it would be 6. 1096. So I would pause and rewind and just think about what I just said there and listen to what that little strategy was again, if I were you, because that'll help you not to have to guess and check a million times to figure out what number to put in next to see which one's the closest. So I will work it out for you to show you, but I knew that it was 144 times divided by 6 would be 24, and I'm going to say it one more time because it's important. 24 times 10 is 240. Half of that would be 24 times 5, which would be 120. 120 plus 1 more 24 would be 144, so I knew 6 would be exactly 144. Okay, and my estimation skills are what they are because I learn on these little multiplication tricks and things like that. So if I wanted to try this problem with partial quotient, I would think of it like this. I know that 24 times 10 is 240. That's not enough. 24 times 100 is 2400. That's not enough. 24 times 1000 is 24,000. Now we're getting warm. So I'm going to start with 1,000 24s. And here's how the book sets it up. They do it this way. From our partial quotient. It looks the same as a standard algorithm, but we do a different process on the top. So I know that 1,000 would be 24,000, so I'm going to take off 24,000. So 1,000 is what I'm thinking initially. Take away 24,000, 4032. I have 2304. So I know that 2400 times 100 would be 2400. So we could do this a couple different ways. I could add another 100 on and then see what the difference between 2400 and 2304 is. That would be 96. And then try to figure out how many. So we went over, we went too far. I know that 24 times 4 is 96. So that would give me no remainder. But because we went too far with the 2400, I would have to subtract 4 from that. And so 1,000 plus 100 is what I'm thinking. That's 1,100, and I'm subtracting 4 from that. 1096. Which is the same answer that I got when I did the standard algorithm. Okay, so partial quotients, just a little different there. When we go a little too far on our estimation, it's tricky to set it up using this model because we haven't really talked about what negative numbers are, and also we don't know how to subtract. Like, it doesn't flow well as we subtract 2304 from 2400. It's basically like a separate calculation that we're making. It doesn't flow very well like this one does. So, yes. It says, how much will Sam's father have to pay each month? Okay, we just calculated that. $1,096. Is that reasonable? Explain. So our estimation was about $1,000, but we had rounded down on his actual price. So we knew that it would be a little more than $1,000. And so, yeah, it's pretty close to what we thought the estimate was going to be. Look back at the division algorithm. What is 24 times 1,096? Well, let's just figure that out. A little review of our multiplication algorithm. 24, 36 plus 2 is 38, 3, 4. Now we're moving over 1, so that was the ones digit, so we started at the ones. Now we're talking about tens. So I need to start my numbers in the tens spot. 2 times 6 is 12. 19, 1, 2, 4, 0, carry the 1, 13, 1, 5, 2, carry that 1, Mr. Gillum, right there. There it is, okay, 26,304. So it is actually what we thought it should be. This is actually saying we have 24 months and I'm paying this much money. So if we did our calculations correctly, after those 24 months we'll have the car paid off. It should equal $26,304. If his father decides to pay for the car in 48 equal monthly payments, how much would he have to pay each month? Ooh, so this changes everything. So it says show your work. We're going to use the standard algorithm division here, and instead of 24 monthly payments, we're going to do 48 equal monthly payments. So if he's paying for it twice as long, he would actually have to pay half as much each month. So I'm going to do this. I'm going to do 26,304 divided by 48 because I think that that's what the skill we're trying to practice. But I also know that if in 24 months he had to pay $1,096, then he would have to pay half as much if he's paying twice as long. So if I divide that by 2, I could also find the answer. So again, I could divide it into 48 pieces, the total price, or since I already have calculated how long it would take him in 24 months, if he has twice as long to pay, he'll have to pay half as much each time. So I know if I do my standard algorithm here, and if I'm going too fast, please slow it down and pause it if you need to. 2 goes into 16 8 times. I think that the answer is going to be 548 because he has twice as long to pay. He'll have to pay half as much each time. Let's check it out with the standard algorithm. 26,304 divided by 48 evenly. Again, I know that 48 doesn't go into 2, or 26, it does go into 263. Here's what I'm going to do to estimate that. I know 48 times 10 is 480. I know that through mental math, and so I know 48 times 5 is half as much, which is 240, and that's really close to 263. another 48 won't fit in. So I know that I'm going to put a 5 and I'm going to put it right above the 3 because that's the last number I'm considering right now. Minus 240 leaves me with 23. I'm going to bring that 0 down. Again, 48 times 5 would be 240. That's a little too much. So I know this time it's going to be 48 times 4. 192. That's 38, and then bring the last number down, 4. Ooh, this one's going to be a tough one. So I know 48 times 10 is 4,800. I know I'm about 100 less than that, so I'm going to guess 2 more 48s less. 48 times 8. I also know that 8 times 8 is 64, and this number ends in a 4. So that will be also another reason that I would guess times 8. 384. And I have no remainder, so 548, and you can see either way I thought of it, I have twice as long, so I need to pay half as much each time. Or if I did the whole thing from scratch, $26,304 divided by 48, $548. So if you're clever, sometimes you can find a division problem that's smaller to do and still answer the question correctly. This is why is it important to pay close attention to place value when dividing with the division algorithm? Well, because if you don't position the digits correctly, you will not know where the decimal place goes and what the value of each of those digits means. So I'm going to show you again. If I'm considering these 3 numbers, 48 and 263, the first number that I put up there goes right above the 3. Okay, in this case, I was considering these first 2 numbers. 2 goes into 10 5 times. It goes right above the 0. Whatever the last number is that you're considering, that's where the number goes right straight above. It says, in a year, or 12 months, a sports team practiced for a total of 1,305 hours, or 1,305 hours. On average, how many hours did the team practice each month? Okay, so I know that a year is 12 months, and we practiced 1,305 hours. So I need to know if it says on average, how much per month that they've done. So this is actually tied into unit rates as well, honestly, because we know how much they practice per 1 month. But I need to figure out what 1,305 divided by 12 is. And we're going to use a standard algorithm because that's kind of where we're moving towards at this point. And we're kind of getting away from the partial quotient, but we can do it both ways, actually. Why not? Standard algorithm. 12 goes into 13 once. And because I was considering 13, I know the 1 goes right above the 3 in the 13. Bring down the 0, goes into 100 0 times. Sorry, 10 0 times. I still have 0 there. And then I have 105. Ooh, it's really going to tell whether or not you know your multiplication facts or not. 12 times 8 is 96. Okay, I can't borrow there, so I got to double borrow. 9 0, so 9 left over, and now I need a decimal point there, and I'm going to decimal point there because I've ran out of whole number digits. Bring a 0 down. 12 goes into 90, or we can, oh, you know what? Let's do a remainder this time. I think that's going to work out a little better. We have a remainder of 9, and here's what that means: 108 remainder 9. That's not a good way to write your answer. Remainder 9 means we have 9 of the next 12. So if we had 108 remainder 9, I would know that's 108 and 9/12, otherwise known as 108 and 3/4. If I reduce this, I know that 3/4 of an hour is 45 minutes. So I have 108 hours and 45 minutes. If I did partial quotients, this one might work out a little easier. I know that I'm going to set it up the same way, actually. I know that 12 times 100 equals 1,200. So I'm going to start with 100 up here, and I'm going to take 1,200 off. That's 105. I know 12 goes into 105. What do we say? 8 times. 8 times, so another 8 on top of that. And that leaves me with 9 there. So I don't even have one more whole 12. So I know that, again, 100 plus 8 is 108, and 9/12, which is really 108 and 3/4 hours, or 108 hours and 45 men.